welcome back, Math75 friends. Now we're going to do section 1.2, and so let's get going on it. Okay, 1.2 is on the addition property of equality. And so they first talk about what a solution is. And so by definition, a solution is any replacement. Remember, they were having us practice plugging in for the variable that makes the equation true. Is called a solution to the equation. And when an equation is true is when the left-hand side equals the right-hand side. And to solve an equation means to find all of its solutions. So we're going to start off by finding things that have just one solution. And then later on in the class, we're going to solve equations that have more than one solution. So right now, that's what we're going to be doing. They give us two properties in your book, but it really is four properties, if you like, for solving. And the first property is the addition property. And it says if you start off with a true statement, A equals B, so we're going to say that this is a true statement, then I can add the same thing to both sides and it still be a true statement. And that's how this would look. So in symbols, A plus C equals B plus C. So if these are balanced with one another, if this is true, then I can add the same thing on both sides. And adding the same quantity, so this is what they're saying in words, adding the same quantity to both sides of an equation will not change the solution set. So this has a solution set, whatever it is, and this has a solution set, whatever it is, but they're the same. And we're going to use that to solve equations is what we're going to use, this idea. And then I tell you, think, if C is a negative number, then adding a negative, do you guys remember what adding a negative is? I was going to circle that whole thing. Ooh, eraser. Adding a negative is the same as subtracting. Or subtraction is the same as subtraction. So you can add to both sides, you can subtract from both sides. So I could have said this: if A equals B, then A minus C, A subtract C, is the same as B subtract C. Great. That would be perfect. So now we're going to try to use this property. The idea is that what you do to one side, you got to do to the other. So if you add to one side, you got to add to the other. If you subtract one side, you got to subtract the other. And the other idea is that you want to leave X all by itself. So I've got X right here, and I would like to leave X all by itself, because then if X is all by itself, I'll know what X is. It'll say X equals, X is. And so the reason X is not all by itself is because of this subtraction of 2/5. And I would like to get rid of that subtraction of 2/5. And so on this side, if I just simply added 2/5 to that side of the equation. Now there's the stack it method of adding it, and there's the write it out to the side method. So if you write it out to the side, it would look like this: X minus 2/5 plus 2/5. If you stack it, it looks like this. But either way, what is negative subtraction of 2/5 plus 2/5? What is that equal to on this side of the equation, which is the left-hand side of the equation? So on this side of the equation, that's going away, right? It's making 0. And so it's really making, on that side, X plus 0. And if you have X plus 0, you just have X, right? So this side is just X. And so this is my thoughts over there, that it's okay to write it in a line. It's okay to write the intermediate step, but when you do the math, you're going to get that. Now, some people will say, well, that's it. That's all you have to do. You got it. The answer is -1/10. But wait. What did it say we had to do? What you do to one side, you got to do to the other. You got to balance it. So I have to add 2/5. That's what I did to that side here. So I either have to stack it, add 2/5, or write it out to the side, -1/10 plus 2/5. Either way, it's all good. So you either stack it like I did here, or you write it like this in a line. you can see why I want to stack it is because there wasn't any room to write that over here, right? I could have added the 2/5 over here. That would have been fine. I have room, and so I wouldn't care at all. Now I want to do this right here. And it's your choice whether or not you do that arithmetic with your head or with your calculator. And I'm hoping that you can do it either way. And so I'm hoping that you will do it with your calculator. So if I'm going to put that in my calculator, I'm going to be putting that in my calculator. My calculator doesn't stack, right? So negative 1/10. So I got that in. I need to go out to the side, and then I'm going to add the fraction 2/5. Downstairs, 2/5 equals 3/10. And I know that's the same as the decimal 0.3, but what they're hoping for in our book usually is a fraction. So the 3/10 is what they're hoping for, a reduced fraction. The good news is that when I do it on my calculator, it will reduce it as well. So 3/10 is the answer. And I just want to show you how to check your answer. So this was x minus 2/5 equals negative 1/10. So where we have x, we're going to put parentheses, minus 2/5 equals, and then negative 1/10. And what we're going to be putting in for x is what we just said it was, 3/10. And then we're going to do this with our head or with our calculator, either way. And we're hoping that the result is negative 1/10. If the result is not negative 1/10, then somewhere over here or somewhere where you were checking it, you made a mistake. A mistake has been made. Okay, so I'm going to use my calculator to check this. 3/10. I didn't put the parentheses around there, even though there were parentheses. Parentheses there were not needed. Remember, I was telling you that if you always put parentheses, you'll get it right every time, but there's times when the parentheses are not needed. And I kind of gave the figure, if you don't use parentheses, you might get it right half the time or 75% of the time, or I don't know what percentage of the time. I'm going to go back and I'm going to add in the parentheses here. So I just kind of arrowed back here and I'll put the parenthesis there. And then I'm going to arrow forward and I'm going to put the parenthesis there. And then what do I have? Minus 2/5. And boom, negative 1/10. Hot diggity dog, that's what I wanted. So this side, the right-hand side, is equal to negative 1/10. And the left-hand side, without doing any work, is equal to negative 1/10. These are the same, so it checks. So this is the answer. Negative 1/10 is not the answer. So I sometimes get people telling me that negative 1/10 is the answer, and it's not. It's 3/10 was the answer. So it's that both sides equal negative 1/10, right? And that doesn't matter. They just have to be the same. Okay, so this is problem 36. I have some distributing to do and some combining of like terms to do before I can use my addition property. And so I look at that and I think, oh, that's complicated. And before I do anything, I just want to look at that side right there. And we were practicing in section 1.1 simplifying that. And so I want to simplify that. And then I want to look at that side over there, right? And I want to simplify that. Well, we were practicing simplifying that in chapter 0. 4 take away 9 is negative 5. And so that's all I want to do is do a little simplifying of that. So I can't add this with anything until I distribute. And these are not like terms, so I can't subtract those. So I'm going to distribute this, so that's going to be minus 2x. And so be with me, guys, here. That's a negative 2. And I know that's really a subtract 5. I know that is. But if I rewrote it, it would be add of a negative. So I really want to think of this as a negative 5. So a negative times a negative is a positive 10, right? 2 times 5 is 10. Plus 3x. And then it would be okay if right now I put negative 5. Because there's only one thing to do over there. And so there I did it. And now my friend Barbara is saying that she's going to bring some cookies over, and she doesn't even know that I'm making cookies. And so there's going to be a lot of cookies at this house. And so that's good. That's how you want your house, with a lot of cookies. So minus 2x plus 3x, right? Minus 2x plus 3x. What do I get when I add those together? And so I hear some people yelling at me, well, that's the same as minus 2 plus 3. Well, what do you get when you do that? Well, you get 1, right? And you attach the x, so this is 1x. And 1 multiplied by x is just simply x. So that's my thought process on that. I wouldn't normally write this. This is what I think. And you'll get where you're pretty good at it and you don't have to think it. You'll think, oh, that's x is what that is. So here I have x plus 10 equals negative 5. And now this side is as simple as it gets, and this side is as simple as it gets. And so now that I've got both sides as simple as they get, that's what you want to do before you try to solve. Now I want to leave x by itself. And the reason that x is not by itself is because of the adding of 10. And so I want to undo the adding of 10. And I would do that by doing the opposite operation of adding of 10, which is subtracting of 10. So I'm going to subtract 10. And yeah, you could write it all in one line, x plus 10 minus 10 if you liked, or you can stack it, your choice, right? Either way, this is in my thoughts, right? And here I can write minus 10 here underneath it, stacking it, or I can write it on this other side as negative 5 subtract 10. My choice, right? This could be my thought if I wanted to, or you can stack it, whichever one you like. Me, I have to admit that I like to stack it, so that here I get 0. X plus 0 is x. And then on this side, what I have here is negative 5 subtract 10. Well, that's the same as negative 5 add, right? Add the negative, add negative 10. And so when I add these together, when I combine them, right, they're both negative, so they're going to be negative 15. They have the same sign. Either way is good. I'm not a person that likes to write it out like that. I like to look at this and say, well, this is the add subtract operation, and this is negative. And if I rewrote this, this would be negative. They're both negative, so you add them and you get negative 15. And I want to check my answer. So negative 2. And where I see x, I am going to be, instead of putting x, I am going to be putting parentheses, right? That's what I'm going to put instead of x. So right here where I have x, I'm going to put parentheses. And what am I going to put inside those parentheses? Yeah, negative 15. And same here. I have x. If I had more x's, I would be doing more substituting. So you put your parentheses where you had x and put inside the parentheses negative 15. And then you could put this in your calculator just like you saw it if you wanted. So you could come here with your calculator and you could say negative 2, parentheses. Well, another set of parentheses, minus 5. And, oh, that's minus 15, girly girl. Talking to myself here. And so negative 15. My handwriting almost got me. Minus 5. I'm going to fix that. Make that better. I needed to write bigger is what I needed to do there. So let's see if I've got it going here. I made that parenthesis bigger so that I could kind of see it, and then I'm going to have this parenthesis, but you can kind of see that I have it on there. Plus 3 and then times negative 15. And I don't really care what this is. It is what it is. And so when I do that arithmetic, I get negative 5. I use my calculator. You could do it by hand. And then this side, I'm going to do it by hand or use your calculator, either one. So that is 4 take away 9, right? Which is also negative 5. And now these two sides need to be equal to one another. Otherwise, I made a mistake. So since they are equal to one another, then that is the answer. If they weren't equal to one another, then I would say to myself, oh, I made a mistake. Let me go and find the mistake that I made. And so that's kind of the story. Sometimes people tell me if they're not equal to one another, that means that there's no solution. And that isn't what it means. It means that you made a mistake. Go find it. And so go find and fix your own mistake. So this one has variable on both sides. So the other two examples that we've done so far on this section on 1.2 is having variable only on one side, but this one has variables on both sides. So what you want to do is you want to get the variables on one side and the numbers on the other. And it doesn't matter which side you move, that you rearrange the furniture to. So this is as simple as that gets. Those are not like terms. There's nothing I can do. That side is as simple as it gets. So that would be the first step before you start any algebra, is to simplify the right side and the left side. I think I said that out of order, but simplify both sides, the right-hand side and the left-hand side. And now I want to get the variables on one side and the numbers on the other, and it doesn't matter which side. So I can tell you that I'm going to put randomly the variables on this side, VAR for variables, and randomly the numbers on that side, NUM for numbers. And so then I can see that 8M is a variable because it's got the M, the unknown, right? And it's got the letter in it there. And I wanted variables on this side. So I'm like, hot diggity dog, you're in the right spot. You're in the correct spot. But this guy right here, right, this guy's a variable. So it's on the right side. I wanted variables over here on the left-hand side, right? I said on the right side. I meant on the correct side, not right and left, right? So I shouldn't say right after that. Too many rights, right. So, but -1, that's a number, right? Subtract 1. So I want to undo that because I don't want any numbers on this side. So I can undo that by adding 1 because that makes 0. And when you take 8M and you add it with 0, you get 8M, right? And that's just a variable. Now, what you do to one side, you got to do to the other. So if you add 1 to the left, you got to add 1 to the right. And I wouldn't add 1 to the 7M because they're not like terms. I could, if I'm going to stack, and I'm going to stack the like terms together. So if you're not a stacker, it might look like 7M minus 3 plus 1. And then it wouldn't matter where the like terms were, you would combine like terms. But I'm going to plan for it as a stacker. And I'm going to add 1 right underneath the -3, subtract the 3, because they're like terms. So when the dust clears, this is a number. -3 plus 1 is a number. You might even know the number that it is. And that's cool, because I want a number on that side. And then, but 7M is not a number. So I want to undo 7M. And this is essentially, you need to take away, right? Because this is, if I wanted to make a 0 out of it, I need to take away 7M. And when I do that, that's going to make 0. And that's cool, because 0 plus that number is a number. And I'm going to have to come over here and also take away 7M. And I'm going to line that up with my variable M, because they're like terms. If they weren't like terms, I wouldn't be lining them up with one another. But the good news, friends, is that's what's going to happen if you carefully do this on separating them, is that you're going to get like terms all lined up with one another. So I have 8M take away 7M. So in my little head, I'm thinking 8 take away 7 is 1, and that's 1M, which is M. So this is M. That's 0. So that's M plus 0 is M. This is gone, right? 7M take away 7M is 0. And then this is, we have -3. Yeah, I could write that as add of a negative, right? So that the 3 was negative, and I'm going to add 1. And that's going to give minus 2. And so 0 take away 2 is minus 2. And so there we have the m is negative 2. So we did a lovely job at the end. We're going to check it. So am minus 1 equals 7m minus 3. A lot of times people don't check their work. Where I have m, I'm going to put parentheses. And then they get the answer wrong because they made a silly mistake. And they say, shouldn't I get most of the points because I only made a silly mistake? And then I usually say, but you had the opportunity to check it and you didn't. And then you could fix your own silly mistake. And so that's what you want to do, is you want to make sure that you're checking things. Now you can check this with your head or you can use your calculator. If you're using your head, you might be saying, oh, that's negative 16, take away 1 is negative 17. And if you're using your calculator, you ought to get the same thing, right? And so whatever you do, your head or your calculator says negative 14, take away 3, that's negative 17. And the thing I have to verify is that these are the same thing. And they are. If they're not, then I know I made a mistake. It could be that I made a mistake when I checked it. That happens all the time. I see people do. So they'll say right here, let's see, negative 14 subtract 3. That's equal to negative 11. I just made a mistake. So now I don't think these are right? I don't think it worked. Well, it's because I made a mistake, right? And so it doesn't matter where I make my mistake. I have to go and try to find my mistake. Or maybe I did a boo-boo here when I did this arithmetic and I said the answer was 4. Then when I plug in 4, the two sides will not be equal to one another. And you need to go and find your mistake. So again, more examples in your book. Check them out. Okay, friends, so that's the few little problems that I did on 1.2. And so you can do more problems if you like from the book. And talk to you on the next video.